Bridge repair day 7. Take you to a familiar rope bridge over a river in the middle of a jungle. Chief isn't on the side of the bridge, though maybe he's on the other side. When you go to cross the bridge, you notice a group of engineers trying to repair it. Apparently, it breaks pretty frequently. You won't be able to cross until it's fixed. How long? Only need final calibration. Some elephants stole all the operators from their calibration equations. They could finish the calibrations if only someone could determine which test values could possibly be produced by placing any combination of operators into the calibration equation, that is our input. Each line represents a single equation. Test value appears before the colon each line. It is your job to determine whether the remaining numbers can be combined with operators to produce the test value. Okay. Operators are always evaluated left to right, not according to precedence rules. Furthermore, numbers in the equations cannot be rearranged. You see elephants holding two different types of operators, add and multiply. Only 3 of the above equations can be made true by inserting operators. The engineers just need the total calibration result, which is the sum of the test values from just the equations that could possibly be true. In the above example, the sum of test values for the 3 equations listed above is this. What is the total calibration result? It's a big one. Now engineers seem concerned. The total calibration result is nowhere close to being with safety tolerances. Just then you spot your mistake. A well-hidden elephant holding a third operator. Concatenation operator would become this. Operators are still evaluated left to right. Now, apart from the 3 equations that could be made true using only addition and multiplication, the above example has 3 more equations that can be made true by inserting operators. Adding up all 6 test values, 3 that could be made before using plus and multiply, plus the 3 that can now be made by also using concatenation, produces the new total calibration result of 11387. Using the new knowledge of elephant, determine which equation could be true, what is their total calibration result. This is also a big one now. Let's see what I did, and you can tell me what you did. All gonna get better. Here I have the input in a string array. Calculate total calibration for input. Parse out the parts. We have the target in first part and numbers in second part. Now we check if it's a valid equation. Generate operator combinations, because the combination will be the total number of operators that we can add is the total numbers minus 1, because we can add an operator between any 2 numbers, so that will be 1 less than the total number of total numbers. we have the operator count. We know the total combination will be 3 to the power of operator count. This is what part 2, by the way. For part 2, we take in all the operators in a string array, the current combination for each operator count. I am getting the current operator by modulo of 3 and repeating the cycle if it's a plus, if it's a multiplication or concatenation. Then I add the operators, get the combination, generate all the combinations. Once I have all the operator combinations, I'm going to evaluate the expression based on the operators. For each expression, I need to check in if my current result that I am getting from this combination operators, add for a plus, multiply for a multiplication, and concatenate for the space. And once I have the result from this expression, I'm checking if it's equal to the target that I have from the first part, and if it's equal, then I return true. Otherwise it's a false and we do not get the target. If it's a true, we add it to our total calibration result, which gives us the result for part 2. Now for part 1, it's a similar approach where I'm splitting for parts and targets, then check if it's a valid equation. Total operator count is 1 less than the total numbers. Then again we check for let's take in this one. For 2 operators plus and multiplication only, we get the total combinations 2 to the power number of operators. For each operator, we create the sequence of operations and add it to our combination set. Once we have the combination set, we go to our validation again and evaluate our expression for each of these combinations. Then again we get the result and then validate and have our answer for the final calibration, that is the total calibration. This is also a fairly straightforward kind of solution where we have 2-3 operators and we have to check if we can make the target by using these operators only. Let's collaborate and see if you all have some other solutions or any shorter, efficient, or I don't know, a different approach maybe. Thank you.